All right, let's take a look at Q equals mc delta T. Now, it's not a formula you have to memorize. If you look in the reference table on table T, under heat, there's a formula right there. Q equals mc delta T. And notice, lowercase q, lowercase m, capital C, and then a capital T, because the other versions of those letters mean something else. So, little q is heat, m is mass, and delta T is the change in temperature. And the capital C is the specific heat capacity. Now, anytime delta is in front of a letter like that, it's going to mean a change in. And we'll take a closer look at that in just a moment. All right, so let's try an example here. How many joules will be given off if a 50-gram sample of water is allowed to cool from 50 degrees Celsius to 20 degrees Celsius? And as always, the first thing we're going to do is write the formula. So Q equals mc delta T. And then we're going to kind of line things up here so we can figure out what's what. So Q equals M equals C equals delta T equals. All right, so how many joules? So that's going to be how many joules for our heat will be given off of a 50-gram sample of water. So 50.0 grams is our mass. And water. So now we have to think about the C, the specific heat for water. And that is easy to find. It's right on the first page of the reference table. In table B, in the specific heat capacity of water, 4.18 joules over grams times Kelvin. Or we could say grams times degrees Celsius. In this case, because the difference in temperature as something goes up 1 degree Celsius or something goes up 1 Kelvin, the same scale. So for this, kelvins and degrees Celsius can be used interchangeably. So it's going to be 4.18 joules over grams, and I'm going to change kelvins to degrees Celsius just because we can. All right, now delta T is the final temperature, so I'm going to put TF, minus the initial temperature, so I'll put a TI. So the water is allowed to cool from 50 to 20. So 20 degrees Celsius is the final, and 50 degrees Celsius was the initial. So the delta T is minus 30 degrees Celsius. And we'll talk a little more about that minus in just a few moments. So now we're ready to start plugging these in here. And we get equals our mass, 50 grams, times our C, times 4.18 joules. I'm going to write it this way. We'll see why in a moment. Grams times degrees Celsius, times our delta T, which is minus 30 degrees Celsius. All right, so now we can cancel out units, and now you can see why I wrote it the way I did. It's a lot easier to see that I can cancel out grams and degrees Celsius when it's written this way. Now I'm ready for my handy-dandy calculator. And as I plug in 50 times 4.18 times 30 will be negative. So I have minus 6270 joules. And now we'll take a look at the negative sign. Now as it cooled off, right, the water cooled off, it gives off the heat to its environment. And that's what the negative sign here means. It means that it's exothermic, it's giving off heat. If it had gained heat, then this would be a positive sign. All right, that's it for question 1.